afternoon, students. So welcome back to Mr. Chen's class. So this one today we'll talk about determinant of matrices. So here's the one. So for sections 7.7, so this one's supposed to be 9.7. So for those who might be wondering inverses of matrices, we'll talk about that after determinant. Is that the way to find inverses of matrix? So that requires the determinant of the matrix. So for those who might be wondering the general structure of finding the determinant of 2 by 2 matrix. So let's say that we do have a 2 by 2 matrix. So we do have A, B, C, D. The way to find out the determinant of this 2 by 2 matrix, so the first thing that you want to do, so you want to multiply the entry of the main diagonal. So this one is kind of like the way we cross multiply, so AD. And then also the product of the minor diagonal, BC. So AD minus BC, then that'll be the determinant of the 2 by 2 matrix. Okay. So what about the one with the 3 by 3? So for the 3 by 3 one, so this one we need to do a little bit more work. Determinant of ABC, DEF, GHI. So the way to find out that the determinant of 3 by 3 matrix, so first thing that you want to do, so you want to find out the minor matrix or the conjunction matrix of each entry. Okay, so, actually you want to select the row or the column first, but it's better to select the row. Okay, so any row, any column. So pretend that we select the first row, so we do have A, B, and C. And then we want to find out the minor matrix of all the corresponding coefficient. So for A here, if we just cover the first row, first column, so the entry that's remain here, we got E, F, H, and I. Okay, so that means we can find the determinant of that 2 by 2 matrix. And then for that corresponding coefficient B here, so we can find out the rest of the 2 by 2 matrix, which is DF, G, and I. And then for C, so the corresponding matrix, then that'll be D, E, G, and H. Again, what I mean by the corresponding matrix, and those are considered the minor matrix. So D, E, G, and H. Okay, so once we set up things like this, so the next step, you want to put in the cofactor. So the cofactor for the standard matrix is always plus minus plus, negative, positive, negative, positive, negative, positive. So check that, positive, negative, and then positive. And then step 3, so basically just evaluate it. So A times the quantity of EI minus HF, and then B times the quantity of DI. So the rest of that, just finding the determinant of the 2 by 2 minor matrix. So DI minus GF. And then the last one, then that'll be C times the quantity of DH minus GE. Like that. Okay, so now let's do one problem like this. 2 by 2, 3 by 3. Okay, so here's what we got for the following. So 1, A and B. Okay, so the first one, 2 by 2. So again, 2 by 2, that's pretty easy to do with. Okay, so determinant of A. So that just multiply the number of the main diagonal. Negative 1 times 5 minus 12 times negative 2. So we got negative 5 minus plus 24. So which is what, 19. And then the 3 by 3, determinant of matrix B. So select any rows and column. So it's better for you to select the row that contains the 0, because that 0 times any kind of a determinant, it's always 0. So determinant of B, so we'll select the first row, 6, 1, and 0. So the corresponding minor matrix for entry, the first entry, 6. So then that'd be 3, 7, 4, 3. And then for 1, the corresponding minor matrix, then that would be considered negative 3, 7, negative 1, 3. And the corresponding matrix for 0, so it's negative 3, 3. Negative 1, 4. And now you want to check that the cofactor. So cofactor is positive, negative, positive. So positive, negative, positive. So positive. This one turns out to be negative. And then this one's positive. Okay, so here's what we find out. So 6 times 3 times 3, 9. Minus 4 times 7, 28. And then minus 1 times the quantity, negative 3 times 3, determinant 2 by 2, so negative 9. Minus negative 7, so plus 7. 0 times the determinant 2 by 2, it's just nothing. So what we find out here, so 6 times negative 19, and then negative 2 plus 1 times negative 1, negative 2 times negative 1, positive 2. So 6 times negative 19, so 6 times 9, 54. 1 times 6, 6 plus 5, negative 1, 14, plus 2. So it's negative 1, 12. Okay, so for the 3 by 3 determinant. Okay, so now let's see what else. So the other one just solve for x. So find out that the setup here for the 3 by 3 matrix. So once we find out that's the simplest form, so we can set up the equation with the determinant 10. Okay, so let's try this one. So solving for the unknown variable in the entry of the 3 by 3 matrix. Okay, so what we got here, so select any row. So this one, select the second row. So we got 0. And then 2. And then negative 1. Corresponding matrix for 0. So we do have x, 1, 1, negative 2. And then corresponding matrix for 2. So we do have negative 1, 1, 2, negative 2. And then corresponding matrix for negative 1, we do have negative 1, x, and 2, 1. So check the cofactor. So the cofactor showing that second row is negative, positive, negative. So negative, positive, negative. So negative, negative, then that turns out to be positive here. So this one, just cross that out. So that's going to be 0. So 2 times the quantity. So 2 minus 2, and not a 0. And then negative 1 times negative, so positive 1. So negative 1 minus 2x. So eventually the determinant, which is what, 10. So now you can set up the equation, so negative 1 minus 2x equals 10. So F1 both sides. Divided by negative 2. So x equals 11 over negative 2. Okay, so now let's see what else that we got. So another square matrix. So square matrix, that means the number of rows and columns, they're exactly the same. So this one's a 4 by 4 matrix. And for those students might be wondering, how do we get the determinant of the 4 by 4 or the 5 by 5 matrix? So basically the way to find the determinant, we just want to reduce down the size of the matrix. So from 4 by 4, we want to convert that to 3 by 3. And then from 3 by 3, we want to convert that to 2 by 2. Okay, let's put it right here for the setup. So 4 by 4 matrix. So normally I like to choose the one with the 0. Does that matter which row that we choose? It doesn't matter. But choose the one that with the small number. And it's easier for evaluation. So choose the 4 row. So we got 0, 2, 1, and 3. So the corresponding matrix for 0, so we do have 1, 1, 1, negative 1, 0, 5, A, 1, 2. Corresponding matrix for entry number 2 right here. So we do have 1, 1, 1. So cover the bottom row and then cover the second column. You'll see that the rest of the number for the 3 by 3 matrix. So 2, 0, 5, and then 0, 1, and 2. And then for 1 here, similar. Cross out the bottom row and cross out the third column. And then you'll see that the rest of the number for the 3 by 3 matrix. So we do have 1, 1, 1, 2, negative 1, 5, and then 0, 8, and 2. And then for 3, so cross out the bottom row and the fourth column. So we do have 1, 1, 1, 2, negative 1, 0, 0, 8, 1. And then check the cofactor. So we do have positive, negative, positive, negative. So this would be negative, positive, negative, positive. Obviously this one is 0, so just cancel. And now for the 3 by 3 matrix, we want to convert that to 2 by 2. So again, the rest of this, you want to select the 0 row or the 0 column. So select that, the third row. So 0. So we do have 1, 1, 0, 5 for the minor matrix. And then for 1. And then we do have 1, 1, 2, 5. And the reason why that I do know it's negative because at the bottom row it's always positive, negative, positive for the cofactor. And then keep going for that 2. So plus 2 times the determinant, 1, 1, 2, 0. So we just take care of that, the scalar times the determinant of the 3 by 3 matrix. And then the next one, similar, so negative 1 times, again, choose the bottom row, so 0 times the corresponding minor matrix, 1, 1, negative 1, 5. So negative, well, this one would be positive, negative, positive. So positive, negative, positive. So 8 times determinant, 1, 1, 2, 5. And then keep going. So positive, negative, positive. Plus 2 times the determinant, 1, 1, 2, negative 1. And then for the third 3 by 3 matrix, so plus 3 times the quantity, bottom row once again, so 0. So 1, 1, negative 1, 0. Minus 8, 1, 1, 2, 0. And then plus 1. Corresponding minor matrix, then that'd be 1, 1, 2, negative 1. And then the rest of that, just find out the determinant. The 1 with the 0, just cancel them out. The 1 with the 0, so I'll cancel. So what's left here? So then that'd be 2 times the quantity. So 5 minus 2, then that'd be 3, so negative 3. Over here, 0 minus 2, negative 2, times 2, negative 4. Over here, minus 1 times 5, 5, minus 2, 3. Okay, so 5 minus 2, which is 3. 3 times 8. Negative, so negative 24. Okay, once again, 5 minus 2, so then that'll be 3. Negative 24. And then plus, right here, so 2 times the quantity, determinant of 2 by 2 matrix, negative 1 minus 2, negative 3. Negative 3 times 2. Negative 6. And then the final group here, so 3 times the quantity, 0 minus 2, negative 2, times negative 8, plus 16 times 16. And then negative 1 minus 2, negative 3, minus 3. And then the rest of this. So negative 7 times 2, negative 14. Negative 24, negative 6, negative 30 times negative 1 plus 30. 16 times 16 minus 3, 13. 13 times 3, 39. And then combine them all together. So this will be 16 plus 39, which is 55. So that would be the final determinant of that matrix A. So the other one is showing that the theorem. So if matrix A is a square matrix, then A has the inverse if and only if determinant of A does not equal 0. If that's a square matrix, so this theorem is always true. The inverse, if the determinant it's not 0. So the inverse is just like finding A, matrix A to the power of negative 1. So that requires 1 over inverse 1 over the matrix A. So in order to get that, the inverse, so we need to get the determinant. Okay, so the determinant of A times certain things here. Okay, it's called the adjugate matrix. Okay, so that bracket right there, it's called the adjugate matrix. And that's something we'll talk about for the next section. So determine whether the system equation has a solution by using determinant. So you just need to verify that the determinant of the 2 by 2 square matrix. So what we got here, so it's 1, 2, convert that to the augmented matrix, and then negative 1 and 0. And then for that, the resulting matrix, so this one is already shown, so it's 4. Because this one's a constant, take that to the right-hand side, so 3 minus 36, so negative 33. So basically what we need to do here, we want to find out the determinant of the square matrix, 2 by 2, 1, 2, negative 1, 0. And this one you find out the determinant, it's negative 2. 1 times 0, 0, minus negative 2, so positive 2. So if the determinant of the square matrix it's not 0, so that means the solutions of the system can be found. Okay? And that's it. Thank you for watching the video today. And stay tuned. So next time we'll talk about the inverse related with determinant. Okay? So we'll talk about that for the next video. So see you later. Have a great one.